Good day, and you're most welcome to today's technical session of the CNPS. I'm Ian Cowan, and today is the 19th of July. Now, today is something a little different from what we've been experiencing recently. We're very happy to have a lecture given by Sankar Hajra. I hope I'm not butchering his name in my pronunciation, but he's from Calcutta, and he's actually very kindly agreed in earlier discussions I had with him to give two talks, one today and a supplementary one in 2 weeks' time. So they're both concerned with electromagnetic fields, electric charges, and light, which he contends possess momentum and energy, which are real physical entities. But furthermore, he says that these physical entities or objects are subject to the action of gravity. And so are those entities, the ones we just talked about too. And he's going to talk about the implications for SR, for special relativity theory, this week. And in 2 weeks' time, the implications of the same objects for general relativity. And I'm probably not spoiling any information by saying that I think his conclusions will be that these elements will cast very severe doubts upon special relativity, and in 2 weeks' time he'll be doing the same thing for general relativity. So it's quite revolutionary. Now he's also sent me a letter just recently, and I think I'll maybe read about 3 or 4 of the points out there because I think they will be useful. Unfortunately, I think it's going to be a little difficult today. Now, as far as I can see, I've only spoken to Sankar Hajra for a little while, just over the last 20 minutes. I think he told me that he has given a talk to the NPA a number of years ago when Greg Vogt was the moderator. I think I said. Now, as far as I can see, his English, as my own experience would indicate, among people on the continent of India, is excellent. Sometimes better than native English speakers, actually, in my experience. However, there is a problem with intonation and pronunciation, which Sankar Hajra has actually confirmed to me. And I think there's going to be a bit of a difficulty, to be frank with you, both ways. So in other words, for us to understand him is a bit of a challenge, but also for him to understand us is a challenge. So I'm just going to ask you, please, to bear with us. And I've asked, I bit impolitely, I've asked Sankar Hajra, his English, he has all the words, but I've asked him to speak very, 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 very slowly. And even to shout out a bit, don't speak very, very low volume. And even to forgive me if I interrupt and say, we just don't understand you. I've actually asked him to spell out a couple of words. So we may even have to spell out a couple of words, A, B, C. I'm sorry about that. But what he's been doing seems to me so interesting that I think it's worth bearing these difficulties to get the information out. I don't want to say, don't understand him, stop the lecture. So let me, I hope these things will help a little. What he said to me is, he said, mainstream professors are well organized, as we all know, but the absurd principles of their profit have lost much of their charm to rationality at present. Their fantasies, so he says, can only influence their career-loving pet students and the slow-witted. Don't mince one's words, that's fine. They will hardly dare disturb the discussion. Okay. So I don't think he's going to concern himself too much with cantering them. But he says, and I like this bit myself, actually, if I may give it my own personal opinion. He says, in the discussion, I shall not propose any theory. I have no theory of my own. I shall only use Maxwell and Newton to reach my conclusion. He also says that most of the anti-mainstream thinkers I know have their own theories. Well, we well know that. He says, they need not disturb me. I shall say nothing about their theories. And maybe that's a blessing as well, because I know that we're all rather opinionated, myself included. and we can write long emails and pick each other up on trivia, and we could just spend the whole 2 hours now debating the different different dissident theories rather. So let's not do that. And Sankar Hajra has said he's not going to do that. I am giving his full name actually in my description. I was asking him, whether it's Mr. Doctor and so on, but I'm not quite sure. So we're just using Sankar Hajra, and he's very kindly always referred to me as Ian Cowan. He says, to Ian Cowan's letter, dear sir, nice and formal letter. So one more point I'll raise. He says, depending solely on Newton-Maxwell, I shall establish in this discussion today that electromagnetic entities are subject to the action of gravity, and this simple consideration will collapse SRT and GRT. So I'm reading this quickly, and I don't want to spoil our speaker's thunder. He'll explain this himself, but it seems to me he's taking gravity to be a very fundamental aspect, which is going to give the lie to some of the generally accepted modern physics notions. Now, it isn't just I who has mentioned this bit about pronunciation, because he asks everyone to forgive him his poor pronunciation and partial hearing loss. So that's what he said himself. And I should be grateful to you if you kindly help me to project my simple views to scholars. So actually, I think what he's saying is he's delighted to be able to talk to us today, because he's getting his information out to the scholastic communities internationally. And we are also delighted to have him here, notwithstanding any of these difficulties. In fact, that's more of a challenge. To me, that makes it more exciting. I have no problem with that. So please, if you have complaints, put them in the chat by all means, and blame me, and make a suggestion as to how I might resolve it. For example, if you say, look, I'm getting nowhere, I'll interrupt the lecture and I'll come in, I'll say, look, you were getting nowhere in regard to what you've just said. Can you spell it out? So I will do that. Right, very well. I'm going to bring Sankar Hajra up. There, you're up now. And so what I have, you might want to say a few words about yourself, which I haven't really expressed properly when I give the floor to you solely. And I have a presentation by you. Now, I've added it there. Perhaps I. Perhaps if you want it to be taken down, I can do that. But what I'll do now is I'll leave the floor entirely to you, so that you have your picture up there and the talk. I'll then shortly maximize the screen, so all we have is your talk, and you can speak through it. As I said earlier to you, it does help considerably if what you're saying is also in print on the screen. That's really excellent, because everybody then will understand it. So if you want to put anything else up, just let me know. And if there are any problems, just say, Ian, please come back. We have a problem. And if you forgive me, I will be looking at the comments. And if I don't understand something you say, I might say, I'll come back and say, please repeat that or spell it out. And similarly, if people make that complaint, I'll do the same. So I hope you'll forgive me for that. But it's important, because what you have to say is so important that I don't want it to go unnoticed. I don't want people to say, I don't know what he's saying at the end of the hour. So I'm going to disappear now and give you the floor, and you can start immediately.
Collapse of relativity. Today we talk collapse of special relativity. Dear colleagues, I bow down to my teachers, Sri Chandra Ghosh of Bajua and Devabruta Ghosh of Reserve Bank of India, Kolkata. I express my gratitude to the late Dr. Michael C. Duffy of Sunderland University for his kind help in pursuing my study on the relativity. I thank Ian Cowan of John Chapel Natural Philosophy society for arranging this talk for me. Electromagnetic fields, electric charges, and light possess momentum and energy that we can experience with our sense organs. Therefore, these are real physical entities, objects. All objects are subject to the action of gravity, and so are those entities too. I would establish in my discussion that this simple consideration will collapse SRT and GRT at once. I've been engaged in studying SRT and GRT for several decades, and I consider both SRT and GRT to be branches of phantom physics. So, nature of space and time. Sir Isaac Newton described his physics within the framework of absolute space and absolute time, each of which is independent of the other. According to Newton, even if the universe are destroyed, absolute space and absolute time would still exist. But Newton's views were very strongly contested by Leibniz. According to Leibniz, space is the order of coexistent phenomena and time is the order of successive phenomena. Therefore, space and time would be relative. If there is no phenomena, there would be no space and no time. Yet, there exists a centrifugal force acting at the surface of our spinning earth. According to Newton's mechanics, centrifugal force originates from the absolute spinning of the earth. Hence, absolute force exists. Both opinions battled for centuries. Euler, Newman, and Maxwell were influenced by the thoughts of Newton. But Berkeley, Boschkovich, Stalo, and Mach shared the views of Leibniz. Mach argued that Earth spins with respect to the fixtures. If a person does not see the fixtures, he cannot settle whether the Earth is spinning or not. Mach proposed that Newton should first stop the spinning of the Earth, then he should rotate the heavens of fixtures around it and demonstrate that there is no centrifugal force acting on the Earth's surface, thereby concluding that the centrifugal force originates from the Earth's spinning. As those feats could not be done, so it could not be said with certainty that the centrifugal force originates from the spinning of this planet. Mach believed that a new system of mechanics could also be developed to explain the centrifugal force acting on the Earth's surface due to the action of rotating stars, considering the Earth to be stationary. However, he was unable to formulate such a system of mechanics. After Mach, it was clear that the absolute space and absolute time of Newton are only his assumptions, the mental construction of Newton. However, everyone in the scientific community rightly believed in Newton's absolute space and absolute time because Newton created a new system of mechanics within that framework which could accurately explain physical phenomena correctly. But from the end of the 19th century, it was known that a good many experiments of electrodynamics were not in harmony with Newton's mechanics. As for example, when a charge moves, its mass increases with speed, which is not compatible with Newton's understanding of mass. When a charge is accelerated in an electromagnetic field, Newton's second law is violated, and the charge cannot exceed the speed of light under any circumstances. Light propagates with speed c in free space, where the Earth is moving with a very high velocity. Therefore, the speed of light should change if measured on the Earth, depending on the direction of the Earth's movement and the direction of propagation of light. But with repeated experiments, it was settled that the speed of light at the same c in all directions on the surface of the earth, a measure of the earth. From the consideration of Maxwell, a follower of Newton, the laws of reflection, diffraction, and interference of terrestrial and astral light should differ, but no such difference was observed. Physio measured the speed of light propagating in a moving medium v is equal to c by n plus 1 by 1 minus s square v, where n is the refractive index of the medium and v is the speed of the medium. This is not in conformity with Newton's understanding of velocity. To explain all those perplexing phenomena, Hendrik Anton Lorentz developed on an ad hoc basis four transformation equations between two frames S and S dash a relative motion which arise follows: x dash is equal to gamma x minus ut, y dash is equal to y, z dash is equal to z, and t dash is equal to gamma t minus ux by c square. K is equal to 1 minus c square by c square root over gamma is equal to 1 by k, E with relative velocity between two frames. These equations are non-Newtonian in appearance. Albert Einstein deduced these four equations, allowing time and space to be relative and time is a linear function of space, using his two well-known assumptions. His assumptions were x dash is equal to gamma x minus ut, x is equal to gamma x dash plus ut dash, y dash is equal to y, and z dash is equal to g, commonly known as the principle of relativity of all physical laws. That is, all laws of physics are the same in all inertial frames, and 2 x square plus y square plus z square c square t square and x dash square plus y dash square z dash square is equal to c square t dash square, commonly known as the principle of light speed constancy, which means that the speed of light is the same c in all inertial frames. Thus, within the framework of special relativity, Einstein was able to construct a new system of mechanics that effectively explained physical phenomena, a dream that had eluded philosophers and physicists for centuries. Therefore, Albert Einstein has been considered one of the greatest philosophers and scientists of the 20th century. But the correctness of the relativity principle of Albert Einstein has not been proved. That is, there is not a single valid experiment to show that the laws of physics are the same in a frame where the speed of light is c, as well as in a frame that moves steadily with reference to that frame. It has been well proven that the velocity of light on the surface of the moving earth is c in all directions. But there is not a single experiment to prove that the velocity of light is the same c in all inertial frames. The surface of the earth is hardly an inertial frame of reference. There is a strong gravitating field acting on the surface of the earth, and therefore, just like all other physical bodies, electromagnetic fields should stick to the earth's surface, and that should be carried with the earth. And in that case, the speed of light in the surface of the earth must be c, which is fully consistent with rational wisdom. This will also explain why all electromagnetic phenomena are independent of our Earth's motion in free space. That is, Earth's surface is exactly equivalent to free space. When an observer at rest on the Earth measures the lifespan of a moving radioactive particle, he finds that the lifespan of the particle increases with velocity. But if the radioactive particle is at rest on the surface of the Earth, and an observer moves in the exact opposite direction and measures the lifespan of the same particle with a justified drop from considerations of Einstein's idea of relativity space, there should also be a same increment of lifespan of radioactive particles. But this has not been shown by an experiment. Therefore, it is clear, just as the absolute space and absolute time were the mental creation of Newton, so were the relative space and relative time the mental construction of Albert Einstein. The only difference is that Newton's assumptions are easy, independent, and plausible, whereas Einstein's assumptions are complicated, interrelated, and seemingly absurd. Isaac Newton constructed the laws of mechanics within the framework of absolute space and absolute time, and formulated the law of gravitation in accordance with his mechanics. Similarly, Einstein constructed the laws of mechanics based on his principles of special relativity, and he formulated the law of gravitation in accordance with that theory, using his principles of equivalence. According to Einstein's principles of equivalence, infinitesimally, the physical effects of gravitation are indistinguishable from the effects of acceleration. This is, however, not at all tenable from a physical point of view at the outset. As an example, when a point charge is at rest on the surface of the gravitating earth, it will not radiate. But if the charge is at rest in a system that accelerates with the acceleration g, it must radiate. Therefore, Einstein's theory of relativity was not based on any reliable experimental foundation from the beginning. Unfortunately, mainstream physicists do not allow anybody to utter even a single sentence questioning the foundation of relativity. In the presentation given below, following Newton and Maxwell, we shall deduce all so-called relativistic effects and explain all the so-called relativistic phenomena from classical electrodynamics. We shall not use any theory of our own. Through our discussion, we believe it will provide a new direction of understanding for physics, nature, and theory relativity. We are now ready to enter the world of electrodynamics. But before entering into this world, we should pay our homage to Newton, Maxwell, and his followers, Oliver Heaviside and J.J. Thomson. We all know a great deal about Newton and Maxwell and Thomson, but we know very little about Oliver Heaviside, sage in solitude. We believe that Einstein borrowed everything of his special relativity from Heaviside, which will be clear from our discussion. Oliver Heaviside, born 18 May 1850 in Camden Town, London, England, and died 3rd February 1925 in Torquay, Devon. Fields of a steadily moving point charge, method for Heaviside, Thomson, and Lienard Wiechert. During Maxwell's time, the electrostatic and electrodynamic potential of electromagnetic bodies was studied by the physicists using Poisson's and D'Alembert equation following Maxwell. After the death of Maxwell in 1879, a group of gifted physicists began to study the electromagnetic potential of steadily moving system of charges and currents in free space. Among them, Oliver Heaviside and J.J. Thomson were the pioneers. Between 1880 and 1900, several distinguished physicists proposed innovative methods for studying the fields of a point charge in motion, building upon Maxwell's consideration. Nowadays, most physicists, as well as relativists, are unaware of these methods. We are presenting below Oliver Heaviside's method to derive the result in 1888 by using the operational calculus, and J.J. Thomson's methods of deriving the result in 1889 by using auxiliary equations. Third, the method of W.B. Morton, published in 1896, the method of G.F.C. Shirley, published in the same year, and the method of Lienard Wiechert. These studies elucidate the origin of phantom physics, which is prevalent nowadays under the name of relativity theory. To reduce the electric and induced magnetic field of a steadily moving point charge, Heaviside began with the inhomogeneous wave equation of the vector potential in the low-range gauge for a moving system of charges as given below. This is the vector potential in low-range gauge. Now we should understand something about steady-state operator. Contention of the steady-state operator is this: for a steadily moving system of charges and currents, the potential at the point x, y, z at the instant t, and the potential at the point x plus u dt y z at the instant t plus dt in free space will be the same, where u is the velocity of the system in free space. If this u is this principle, we will get the steady state operator d dt minus u d dx. This is steady state operator in electrodynamics. This is a mathematical procedure through which the T function of inhomogeneous wave equation for the vector potential is eliminated in favor of x function. Heaviside began with the inhomogeneous wave equation of the vector potential and then applied his operation calculus followed by steady state operator to derive his result. He, not Einstein, was the first to deduce the field of a steadily moving point charge in 1888, well before 1905. However, relativist attribute the credit to Einstein. Heaviside method. The vector potential of a steadily moving point charge are deduced by Heaviside using his steady state operator and his operation calculus. Heaviside, the sage in solitude, calculate correctly the induced magnetic field and the field for a steadily moving point charge directly for inhomogeneous wave equation for vector potential by the steady state operator and the operation calculus involving the denotation for the differential operator, a method of solving differential equation by transforming them into ordinary algebraic equations, which caused a great deal of controversy at that time. Heaviside starts his calculation with the inhomogeneous vector potential in Lorentz gauge as given below. He starts from this equation, then he uses his operational calculus and get this equation, equation 8. It is a very important equation in his deduction. Then he uses steady state operator. Here he is using steady state operator, and after using steady state operator at some algebraic calculation, he comes to the result induced B field as this and electric field as Q1 minus E square by C square 4 pi 0 r square 1 minus E square by C square sin square theta 3 by 2. This equation 22. This is a very important equation in electrodynamics. It is used by relativity all the time. But they do not confess that this equation has been derived from Heaviside electrodynamics. A little, you see, kindly see this equation. This is a very important equation. This equation guides all field of electrodynamics. A little observation will show E is real and induced B is circular, and from this we get magnetic field, induced magnetic field U by cos E by C square. Heaviside first observed that the field of a steadily moving point charge are similar to those of a similarly moving charge electrode, having the contacted axis to a direction of motion. The axis is contacted by the factor 1 minus E square C square. The Heaviside first deduced the electric and magnetic field of a steadily moving point charge in 1888. The quantity 1 minus root over 1 minus E square by C square. The vital equation used in special relativity is coming from Heaviside's work, not from Albert Einstein. Relativity propagandists use regression with Albert Einstein, not referring to any contribution from Oliver Heaviside. All electrodynamic calculation of special relativity are based on above relation. Heaviside framed the operator method for solving linear differential equation algebraically. Thomas Bromwich supplemented Heaviside's operator method by providing a rigorous mathematical basis known as the Bromwich integral. Heaviside's operator method is more or less similar to the modern approach of using Laplace transform. E.J. Barr has used Heaviside operational calculus to engineering and physics. A beautiful analysis of Heaviside's operational calculus is given by E.T. Whittaker in the Bulletin of Calcutta Mathematical Society. D.H. Murray has used his operational calculus to study many mathematical problems in electricity and magnetism. Defect. There is a defect in the calculation as mentioned by Charlie. Heaviside reduction should be valid for physical charges too, but that is not the case. Therefore, the reduction needs some physical clarification. Then comes the Thomson method, auxiliary equation used by Thomson. In 1889, in order to study the fields of a steadily moving charged sphere, Thomson assumed that the field of a steadily moving charged sphere should be radial, as those of a steadily moving point charge. He showed that the fields of a steadily moving charged sphere are exactly the same as those of a steadily moving point charge, as deduced by Heaviside. Shirley pointed out that the assumption of Thomson was not correct. Therefore, his deduction too was not correct. However, in his deduction, Thomson transformed electrodynamic equation in electrostatic format and put forward a new direction of solving electrodynamic problems electrostatically. His deduction could be presented in the following form in the present context for a point charge steadily moving in OX direction. The Thomson starts from this equation. This is electric field of a steadily moving of a charge. This is electric field. He then differentiates with respect to t, and after using steady state operator, he gets this equation. Then now Thomson proposes some auxiliary transformation equation, that is x equal to gamma x, by k is equal to 1 minus c square by c square half, gamma is equal to 1 by k, by which he transforms this equation in static electrostatic format. This is electrostatic format. And from this, he deduced the electric field of a steadily moving point charge by the following equation. This is the equation. This is the equation E field. This is the equation deduced by Thomson. This is same as the Heaviside's electromagnetic electric field. Defect. Thomson made his calculation for a steadily charged sphere, but after the analysis of Shirley, as mentioned earlier, it was known that the field of a charged steadily moving sphere is not radial. Therefore, the calculation fails for steadily moving charged sphere. Therefore, this calculation is valid only for a steadily moving point charge. A third important reduction of the fields of a steadily moving point charge has been done by A. Lienard and W. Wiechert. This reduction has been well presented in many textbooks published in the third quarter of the past century. Recent textbooks are avoiding the reductions. We have presented an abridged reduction in the appendix A of this talk. Now we see the Lienard-Wiechert reduction. Lienard-Wiechert reduction, it is assumed that the electromagnetic force proceeds with the speed c, which is the outcome of the Maxwell's wave equation. The wave, that is, the electromagnetic disturbance, travels with speed c, hence, the electromagnetic force too proceeds with the same speed. This is Lienard-Wiechert potential. This is the x1 or x2, the line charge, but the retarded position is x1 and x2, and the action at P, the action as is considered from the action of the retarded line charge x1 and x2. From this consideration, with the very algebraic and geometric processes, Lienard-Wiechert has deduced the same potential equation for vector potential, induced vector potential A Astral, and from which the Heaviside field could be deduced. The defect. The deduction is easy and simple, however, it presents no insight into electromagnetic processes. Then comes the deduction of Morton and Shirley. From 1880 to 1900, several distinguished physicists proposed interesting methods to analyze the field of a steadily moving charge ellipsoid based on Maxwell theories. Today, most physicists and relativists are unaware of these methods. Two below, we present the method of W.B. Morton's method, deriving results in 1896, using Heaviside, and J.F.C. Shirley's method for deriving the result in 1896 and 97 using Heaviside and Morton. Morton started with the electric potential of a charge ellipsoid at a point where there is no charge. From this he deduced, with elaborate calculation, he got this equation. this equation. This is the same as the Heaviside electromagnetic field. This is the scalar potential for a steadily moving point charge, from which we could easily reduce the Heaviside field. Similarly, Charlie started from the two conjugate equation and do conjugate potential systems, high potential, omega potential. They did not use phi potential or A potential. They used psi potential and omega potential. From these, he deduced the electromagnetic field of a steadily moving point charge similarly by this equation. This is the Heaviside. This is same as the Heaviside's calculation. This is same. The field of a steadily moving point charge. This is the potential. Now, from this, he calculated with elaborate mathematical uses. He calculated the magnetic energy of a steadily moving point charge like this by equation 76. The equation 76 represents the magnetic energy of a steadily moving point charge. This was first deduced by Charlie in 1890. We can easily deduce the electromagnetic momentum of a steadily moving point charge from the equation as given below. Relativity electrodynamics is solely based on the classical equation of electrodynamic momentum. This is reduced by this is kinetic energy, and from this we can easily deduce electromagnetic momentum as this equation. P electronic momentum q square u 650 c square dr. This is electronic momentum point charge. Here is a k factor here. That is electronic momentum is gamma times greater than the static electromagnetic momentum. Equation 81. This equation 81. This equation 81. Could explain many pioneering electronic phenomena from the consideration of classical physics without the use of any iota of the special relativity theory. This author has independently derived an equation in chapter 4 of this book in section 3.9. Abram contribution. Max Abram in 1900 developed his theory of the electron in 1902, in which he hypothesized that the electron was a perfect sphere with a charge divided evenly around its surface. He beautifully calculated the electromagnetic momentum, electric energy, magnetic energy, longitudinal and transverse electromagnetic masses of a steadily moving spherical charge. Now comes the age of auxiliary transformation. Auxiliary transformation in classical electrodynamics and their application. Poisson equation determine the potential of stationary system of charges and currents, and Maxwell equation describe radiating properties of stationary radiating bodies. Now the questions arise: when those electrodynamic bodies move in free space with steady motion, what should be the potential of those steadily moving electrodynamic bodies? And when the radiating bodies move with steady motion in free space, what should be the electrodynamic properties of the steadily moving radiating bodies? Thomson invented three auxiliary phase transform that transform the equation of the magnetic field of a steadily moving system of charge into an auxiliary electrostatic format. He thereby solved electronic problem electrostatically. Lorentz used this procedure eagerly to study potential in moving system of charges and ultimately invented an auxiliary time transform that converts Maxwell equation for a steadily moving system of radiating bodies into the same auxiliary electrostatic radiation format. He thereby resolved electrodynamic radiating problem electrostatically. The three auxiliary space transform of Thomson along with the auxiliary time transform of Lorentz are collectively called auxiliary Lorentz transforms. These four auxiliary transforms of classical electrodynamics are contributions from Heaviside, Thomson, Morton, Schuster, Charlie, Lorentz, and many others. In this talk, we have traced Thomson auxiliary space transform arranged by Lorentz to study dynamic potential problem, and then have deduced the auxiliary time transform of Lorentz directly from Thomson's three auxiliary space transform classically. We have also demonstrated that those four auxiliary transforms can explain numerous electrodynamic phenomena classically without relying on any aspect of special relativity theory. Nowadays, people have forgotten the ingenious application of the four auxiliary transform in classical dynamics. In the first part of this paper, we shall show how Lorentz used Thomson three auxiliary space transform to determine the potential of a moving system of charges. In the second part of this paper, we shall show how the auxiliary time transform to Lorentz can be constructed using Thomson auxiliary equation and how it works for solving radiation problems of moving radiating bodies. Auxiliary equation in classical electrodynamics. Inhomogeneous wave equation in Lorentz gauge for potential of moving electrostatic system. This is the electrostatic potential in Poisson form of a stationary system of charges. Now it moves, we convert to this equation 2. This is the dynamic potential. Now this is steady state operator. This is steady state operator. By using the steady state operator and this equation, that is auxiliary phase transform. It is a very interesting method used by Thomson. Auxiliary phase transform initiated by Thomson and transformation of inhomogeneous wave equation of potential in Poisson format. This equation will transform, the auxiliary transform will transform this equation to electrostatical format and will give a relation between a potential of a moving system with an auxiliary system. This equation is deduced by Lorentz. Phi dash is equal to gamma phi dash. That is, this equation means that we see that potential of a moving system of charges S is not connected to the potential of same system at rest S0. The potential is related with the potential of the stationary system in which all the coordinates parallel to x, y, and oz have been changed to the ratio determined by the equation S dash. By this equation, if we have to extend and we have to construct an auxiliary system by this equation, and first we have to determine potential at that system, and then we should connect the auxiliary potential with the real electrostatic potential in moving system. This is the procedure. From this procedure, you see that the same from this we have come the auxiliary potential. This is auxiliary potential. From the auxiliary potential, we get auxiliary field, and from this auxiliary field, we get the relation between the exact electromagnetic field with the auxiliary field. This is the equation are used by relativity. Electric and magnetic field are steadily moving electrostatic system with an independent field and an independent field and the relation with the auxiliary field. When a system moves with a steady motion, then its real field will be connected not with the stationary field but with the auxiliary field. This auxiliary equation used by relativists is not a relativistic equation. These are equation of classical electrodynamics. These are the auxiliary relation between real electric field and auxiliary electric field. These are used by relativity. These are classical equation. Then we show that the velocity of point charge in a steadily moving electromagnetic system. Suppose a charge is moving with velocity v in a stationary conductor. What will be the velocity v of this charge in the conductor when the conductor moves with the velocity u? This equation, this is the classical equation, not from relativity. This has been directed using Thomson and Heaviside. This equation will use Thomson and Heaviside. Now, from this we have deduced the electric field. We have deduced electric field, magnetic field, electronic momentum, and kinetic energy, that is m0 mu c square by m0 c square. The same equation I use relativity. These equations are classically derived. Now these are the full reduction. I have reduced it synoptically, but these are the full reduction. These are the full reduction. We see that when a system with an independent electric field originating from a charge of any shape and size and an independent magnetic field originating from a current flowing within the system in an arbitrary direction is steadily moving with a velocity u in the wave direction, we get the following relation adding same component of fields together in equation 16 and 17, the equation. We get the auxiliary field equation used by relativist. Now we have deduced the theory of experiment here by using this equation. Theory of experiment, that is addition velocity, we get this equation. From this we get theory. We can easily explain theory of experiment. Now derivation of E field, B field. Now comes the derivation of auxiliary Lorentz transformation equation. This is the deduction by which we have shown that x dash is equal to gamma x minus ut auxiliary equation, y dash y, z dash is equal to z, t dash is equal to gamma t us minus v square. All the equation has been deduced classically from the equation classically from radiation equation of Maxwell and auxiliary radiation equation of Maxwell. The equation has been deduced. This equation has been d dash equal to gamma t. They are auxiliary equation but not real equation. And by this all radiating problem could be solved classically. The deduction of E field and the B field of a steadily moving point charge by Heaviside is a pioneering work in the 19th century. Depending on the deduction, Thomson invented his three auxiliary phase transform to study electromagnetic phenomena electrostatically. Lorentz used this procedure to study dynamic potential problem in electrostatic format and extended this procedure to study dynamic radiation phenomena by introducing his auxiliary time transform. Using classical Lorentz transform, we have deduced in this article the velocity of light in the moving dielectric, velocity of a point charge in a steadily moving electric system, the electric and induced magnetic field of a steadily moving point charge, its electromagnetic momentum, longitudinal and transverse electromagnetic masses, its energy, and the relation of radiation properties of steadily moving radiating system with its stationary counterpart, a classical and other things. Collapse of special relativity. In the previous discussion, we have shown that using classical electrodynamics, that the electric and magnetic fields, electromagnetic momentum, longitudinal and transverse electromagnetic masses, and the kinetic energy of the steadily moving point charge are under. These have been deduced previously from classical electrodynamics. However, these equations are no way related to large charge of material bodies. Relativists extend those equations to large charges of material bodies as well, based on their metaphysical understanding of the physical world. We will now proceed to explain various electronic phenomena using those results easily and rationally. Transverse Doppler effect. This is a mainstream propaganda that the transverse Doppler effect cannot explain from consideration of classical physics. This propaganda is not correct, as we see under. The electromagnetic force acting inside a radiating dipole determines its frequency and oscillation and the period of oscillation. Now, when the dipole steadily moves perpendicularly to a direction of oscillation, according to Heaviside formulation, the electromagnetic force inside the steadily moving radiating dipole will decrease by this factor, K. And for this, a dipole and a dipole radiates when its electromagnetic force acts within it. When the dipole moves, its field within it changes. As a result, the frequency and period of oscillation of the moving dipole changes according to the following classical equation. This is the oscillation of a dipole when it is at rest, when it moves. This will be the equation from electrodynamics, and there is a gamma factor here is coming due to the Heaviside electrodynamics, and the force inside it changes to F0k, and therefore the frequency also changes inside it. Omega 0, 1 minus c square by c square. This is the transverse Doppler. This is explained from classical electrodynamics. So-called time dilation. Now, if the frequency changes, time period also changes. Thus, t is equal to gamma t0. Thus, the period of oscillation of the above moving dipole increases with the velocity in free space. There is also mainstream propaganda that the increment of lifespan of moving radioactive particles could not be explained from electrodynamics or Maxwell. The propaganda is not too correct, as we see below. A radioactive particle decays when electric and magnetic forces inside the particle act to disintegrate the particle. When the radioactive particle moves, the electric and magnetic force acting inside the particle decrease, and consequently, the disintegration process in the moving particle changes, and the disintegration process in the moving particle decreases, and the lifespan of the particle increases as per the following electronic equation. When it rests in the free space, the disintegration equation is determined by this equation. When it moves, F0 inside it changes to F, and disintegration process will obey this equation 20. Now, if we compare, we will get Ft, F0. If we compare F0 and Ft, we get T equal to gamma T0. That is lifespan of radioactive particle increases with velocity. This analysis has not been said. Here is one time, and there is another time concept, as well as the twin paradox of relativity. And this is the velocity of dielectric, velocity of light in a dielectric. I have used here the velocity addition theory as deduced from classical physics, and from this we get this equation. Piling electronic phenomena. Maxwell equations of electromagnetic fields are applicable only in free space, and inside systems piling electrodynamic phenomena linking Maxwell with Newton. Maxwell equations of electromagnetic fields are applicable only in free space, and inside system stationary in free space. One would then expect some correction, modification of Maxwell equation when the electronic phenomena are studied on the surface of the Earth, which is moving with high velocity in free space, but those corrections are not needed. All electronic phenomena like reflection, refraction, diffraction, interference, etc., as observed on the surface of the Earth, either with starlight or with Earth light, are independent of the movement of this planet. That is, Earth's surface is exactly equivalent to free space for a description of electronic phenomena on it. Electric and magnetic field possess moment energy, which we could experience with our sense organ. Therefore, electric and magnetic fields are real physical entities. All objects are subject to gravitation. They are carried with Earth at the near vicinity of the surface. They spin, translate, and rotate too with Earth at its surroundings. The electric and magnetic field should similarly be subject to gravitation and should similarly be carried with Earth at its near vicinity. They should similarly spin, translate, and rotate too at the surroundings of the planet. Electric and magnetic fields originating either from Earth or Sun or from the stars existing at the near vicinity of the surface should be carried with Earth and should spin, translate, rotate with Earth and exactly the same way as other physical objects do. This will at all explain the piling electromagnetic phenomena easily and rationally. In a laboratory, Troughton-Noble experiment. In a laboratory, when a charged condenser moves, the electric field around it changes, and thereby a magnetic field is created around the condenser. If the electric field originating from the condenser were to move along with the condenser, there would be no change in the electric field around the condenser, and thereby there would be no magnetic field around it. Now a condenser, it has rest on Earth's surface, moves with Earth, but electric field around the condenser too moves with it, and therefore there should be no magnetic field around the condenser when it is stationary on the surface of the Earth. which is moving with high velocity in free space. Therefore, the Tauton Noble experiment fails to detect any magnetic field around the condenser. This implies that the Earth carries condenser along with the electric field. This is Tauton Noble experiment. The Michelson mold experiment. Earth translates along with air, water, and electronic fields at the vicinity of its surface. Therefore, the motion of Earth should have no effect on the velocity of light in air or water when measured on the surface of the Earth. This will at once explain the null result of the Michelson voltage experiment in air and the Muscat jamming type experiment in water at rest on the Earth's surface, and may give some insight to understand why all electromagnetic phenomena as observed on the surface of the Earth are independent of the motion of this planet. So this is Thomas and Miller experiment, where the Michelson experiment has been performed with starlight and sunlight. Similar null results have been confirmed. This can only happen if the electric and magnetic fields originate either from Earth, star, or from the sun, and existing at the near vicinity of the Earth's surface, being translated and rotate with the Earth. This is Sankar experiment. Here there is a phase shift, and Sankar effect proves that direct tangible experiment light speed is relative and not absolute. The Michelson Gale assisted by Pearson. Earth carries electronic field along with it, and thereby light at the vicinity of the surface should be affected by the Coriolis force due to the spinning of the Earth. That is, the light is coming in circular motion, Coriolis force acting, and it will be drawn toward the center. And this light, when the rotating disk, the light will rotate, then it will go outside, and therefore due to Coriolis force, there will be phase shift in the Michelson-Gale experiment. This is the phase shift, Michelson-Gale experiment. Happily getting experiment. During October 1971, 4 cesium atomic clocks were flown on regularly scheduled commercial jet flights around the world twice, once eastward and once westward. From the actual flight paths of each trip, relative to the atomic time scale of US Naval Observatory, the flying clocks lost 59 nanoseconds during the eastward trip and gained 27 nanoseconds during the westward trip, where the errors at the corresponding standard deviation. Taking an atomic clock in the oscillation of a point electric charge due to an elastic force acting inside it, ticking on an atomic clock is the oscillation of a point electric charge due to an elastic force acting on the point charge inside the clock. Now, since electric charges are real physical entities, they should be subject to gravitation, and the Earth carries the charges in its vicinity of the surface. Therefore, orbiting atomic clock should experience the gravitating force of the Earth. It should also experience the Coriolis force due to the Earth's spinning when the atomic clocks are in rotation with respect to our surface. Therefore, when an atomic clock moves with respect to the Earth's surface due to the change in elastic electric force inside the atomic clock, a magnetic field originates inside the clock, and thereby elastic electromagnetic force inside the clock changes, and that affects the ticking of the atomic clock. This is first factor for contribution to the time gain or loss of the steadily moving atomic clock as per study. When the atomic clock moves with the aeroplane, the clock, being a part of that system, is carried with the Earth, and therefore there should be experienced a Coriolis force, which must affect the ticking of the atomic clock. This is the second factor for the time gain loss of the steadily moving atomic clock. And when 3. The atomic clock is taken to high altitude, the clock has to work against the gravitating force of Earth. This would affect the ticking of the atomic clock. This is third factor, acting for the time values of the. We have calculated all these effects from classical contribution and shown that our calculation results are as follows. For the eastward trip, time loss is 35 nanoseconds, and for the westward trip, time gain is 270 nanoseconds. The result more or less corroborate to the observed result. These are the calculation. These are the calculation. This is calculation from our calculation electromagnetic correlation gravitation net effect. Apparition of astral and terrestrial light. The observation of Bradley, Airy, Jaffe, and aberration of light. Aberration of astral light. The first picture represents Bradley aberration. The first picture represents Bradley observation. The telescope is filled with the first telescope is filled with water, and the telescope is then Airy observation. Telescope is filled with water. The first picture represents Bradley observation. The telescope filled with air. The second picture represents Airy observation. The telescope is filled with water. In both the cases, the aberration angle is the same. Why? No tangible expansion from special relativity. In Jaffe observation, there is no aberration light coming from the mountain top. Why? Let us watch the journeying of a light ray from the surface of an overhead star to the surface of the earth. As long as the ray is at the surrounding of the star, it will be carried with the star. When the earth traveler comes to the surrounding of the sun, it will be carried with the sun. Then it will come near the electronic field coverage of the earth, where there will be an apparent relative motion between the two. Therefore, the ray will strike the electronic field coverage of earth at an angle theta, such that theta is equal to u by c. Then it will enter into the surroundings of the earth and will be carried with earth. Therefore, when Bradley sees the overhead star through a telescope, he finds that the aberration angle is theta, such that tan theta is equal to u by c. When u by c are neither related to this space, not to astral space, u and c are the velocities of earth and the ray with respect to the solar space, as has been observed by Bradley. Now, if the telescope is filled with water, the velocity of light inside water must be c by n, but there will be no relative motion between the ray and earth, as earth is carrying the electronic fields along with it. Therefore, the aberration angle will remain the same as observed by it. More interestingly, in such a situation, a ray coming from a mountain top has no aberration as observed by Jaffe, as there is no relative motion between the ray coming from the mountain top and earth, because earth carries the ray along with it. All these imply that electromagnetic entities are subject to gravitation, and at the near vicinity of their surface, the entity, just like all other physical objects, translate, rotate, and spins with the translation, rotation, and spinning earth, and experience correlations force while in motion. And this classical consideration, along with Maxwell electrodynamics, will explain all pioneering electronic phenomena easily and rationally, and thereby overthrow special relativity from the domain of electrodynamics at a stroke. This is large charge electrodynamics. Both large charge electrodynamics calculation from Maxwell and relativist calculation from Einstein concur on the electropoint charges. The electric field, the magnetic field, and electromagnetic momentum, longitudinal electronic mass, transverse electronic mass, and energy of a steadily moving point charge are the same in both calculations. These two for electromagnetic body acting on moving point charge, transverse Doppler effect, and incremental lifespan of moving radioactive particles. Similarly, phase shifts of the physical experiment as well as laws of reflection. Similarly, phase shifts of the physical experiment as well as laws of Similarly, phase shift of physical experiment as well as laws of addition of velocities of steadily moving charges inside a moving conductor calculated from the two different approaches are precisely the same. However, the result of the different calculation methods differ markedly for large electronics. That is, for cases where the moving charge body or moving charge itself occupies an appreciable volume or surface area in space. For example, the electric field, magnetic field, electromagnetic momentum, energy, longitudinal, and transverse electronic masses of a steadily moving charge spheroid, charge electrosphere, or charge large body differ accordingly to calculation from two different approaches. This too is true for the electronic force acting on charge large body while the moving steadily. The magnetic fields originates from the surface of the currents and volume currents flowing within the moving system in any arbitrary direction, and it also applies to the single angle of radiation from a steadily moving radiating body. The most interesting difference arises in the calculation of effects of electronic system. Usually or not, an observer measuring the effect moves on it. Therefore, the mission of special relativity can be partly successful if the result of the experiment of the second category stated in the previous paragraph conform only to the calculation from special relativity. Unfortunately, relativists are innocently unaware of this crucial situation. The goal of our presentation is to demonstrate that auxiliary Lorentz transforms are unique classical tools for studying electromagnetic phenomena in moving systems. But these equations could in no way explain the null result of the microscopic experiment. To explain that null result, Albert Einstein assumed that the Lorentz transformations are real, and this is known as special relativity theory. According to this theory, bodies contact with motion and time directs therein, a phenomena that gives rise to a phantom world. In that case, the experiment will yield a null result. On the other hand, we have presented evidence that all electronic fields are real and hence subject to gravitational forces. In that case, the electromagnetic field will be carried by the earth. When the earth translates, rotates, and spins, these fields will similarly translate, rotate, and spin with it, experiencing the Coriolis force when the field vibration moves with respect to the earth's surface. This will immediately explain the null result of the microscopic experiment and the non-null result of the microscopic experiment. Assisted by Pearson, this will provide insight into the way why the surface of our planet is exactly equivalent to free space. This world we think is real, not a phantom world. What do you think, colleagues? I have trouble hearing. Please ask me questions in writing and I will respond to you in writing as well. In the next talk, we will demonstrate that our above classical consideration can easily explain all gravitational phenomena. We will prove that general relativity is also a form of phantom physics. Thank you. এটা কি করবো আগে? বইটা বলবে বইটা না বই কত বড় স্টপ বলো স্টপ স্টপ
Okay, thank
Hello?
you very much. Can you hear me?
Yes.
I take it you've completed that, and I do apologize. I think my fear mongering was not totally justified. When I was speaking with our speaker privately, I think we were finding it difficult, frankly, to understand each other. But in the talk, you were more clear. You spoke slowly and you articulated your words. And also, we had the benefit of having your text in front of us. What I did actually is I maximized that text so I could read it, and therefore I've probably missed a lot of the questions. So you'll forgive me if I take a moment or two to come back in a moment to them. But thank you very much. That's most stimulating, and you've gone through a lot of material there. In just over an hour, and actually, I would say that the conclusions you've reached are, I think, consonant with what many of us have been dealing with. I mean, for my own part, I think they're very similar to the conclusions that I have reached. And I'd like to look at this in very, very much more detail. I take it that this big thing, what do you call it, linking Maxwell with Newton, that's actually a textbook that you've written, is it? It's a book. I mean, I saw like it has 100 or more pages. I'm just asking that question. Okay. Well, maybe one or two observations before we get to the questions then. There's so many points here. I'll not labor the point now. I'll get to the questions quickly. But I see, for example, that I think Sankar Hajra's thesis is that there is a dragging of of a medium, like you might call it the ether. I think you haven't actually used the word ether, but there's a dragging of it, which is basically caused by gravitational interaction. There's a bit of a debate as to how far gravitational versus electromagnetic radiation takes place. So that's the point. And you've quite interestingly enough dismissed the mainstream idea that, how could you explain transverse Doppler without relativity, and the Lorentz transformations are actually real time dilations and real space contractions rather than tools. Well, maybe we'll come back to some of my points because I'd like to go into more detail about this. But I'll just, with your permission, go quickly through the main questions. Not many of them were coming through initially, and I feared that people were either confused or perhaps they were enthralled. I see that Professor Hallam Butiev has come in. He says, I agree with presentation of space transform for a Poisson equation of moving charge. Beckmann presents the same view in Einstein plus 2. However, it must be emphasized that this is a trick. Now, he also says, nowadays we should not use such trick because it is misleading and make people misinterpret the auxiliary variables. Heaviside was against Lorentz use of time and space transform. Have you any comment on that, Sankar, Hajra? I think the gentleman there is probably helping with the interpretation.
No.
Yeah. Okay. It's just any comment, good, bad, or indifferent, on Hallam's comments there. I think that you can think about that. He makes another one. He says instead of using auxiliary variables, one should resolve the equations as is by using computational techniques. Yeah, well, I think Hallam has sort of given us some presentation about his own work in that area. Let me see what Robert Kay says. Sound to me like Sankar is deriving SR using Maxwell and others of his day. They did not see what Einstein saw. It is obvious now that these ideas are derived from Maxwell. Have you any comment on that? I think he's probably disagreeing to a certain extent, if I may try to interpret this, I hope not incorrectly, that he says that you're effectively getting the same thing as SR. Okay, if you have any comments, well, or should I say Lorentz rather than Einstein? Lorentz and Einstein. Okay. Yeah, well, maybe just in a nutshell, Robert Casey, this is awesome magic. SR without Lorentz or Einstein. So, but I think you, Mr. Speaker, wouldn't accept any form of special relativity, not even a neo special relativity. You think it's groundless, don't you? Okay. Let's see what he says about that. I hope you can understand what I'm saying, because I fear that there's a greater difficulty in interpretation from me to you than from you to me, because I could basically understand what you were saying, but you're not responding to the question. So I don't know if that means you agree or you have nothing further to say. But anyway, let's proceed. Okay. Okay, you have taken a little longer than the hour, or maybe that was owing to my introductory remarks, which I thought might be helpful. So we don't have that much time for further discussion. So unless you want to raise any points in relation to my points that you're discountenancing the ideas of special relativity and time dilation and length contraction. You've talked about atomic clock retardation and so on. And unless you have any comments on those, we'll get to the green room now. When you were quoting Thomson's work, I think you were dealing with J.J. Thomson, the discoverer of the electron. I first thought you were dealing with Lord Kelvin's work, but I think it was J.J. Thomson. Okay, just contradict me if what I say is wrong. I'll leave it at that. Okay, now private chat. Okay, we have actually we had two people whom I hadn't recognized in the room. We have a gentleman by the name of Gianfranco Spavieri. He says, "Excellent, Sankar. There are points where I do not agree. For example, the Sagnac effect. But I agree with the important notion of the Earth being equivalent to an inertial frame, Stokes-Planck theory." Now, I can't put comments up from the green room up on the screen. So what I'm going to do with Gianfranco Spavieri's permission, and I hope I'm not making a mess of pronouncing your name, I'm going to add you to the thing. So good day to you. I haven't met you before, but you're welcome. Would you like to expand a little on what you've just said in the comment there to Sankar Hajra? Can you hear me, Mr. Spavieri? No, he's not responding. He's in the green room, and he's made... Mr. Spavieri, you can't hear me. You're not responding anyway. I'm surprised about that. Anyway, I'll have to remove you then. He says he does not agree with regard to the Sagnac effect, and I don't know what his disagreement is about, because I think you've probably given the correct magnitude of that and maybe even equation. And maybe the Earth being an approximate, I say approximate, inertial frame might not be very far from your ideas or indeed mine. ECI frame. Okay. Anybody else would like to come in? I'll bring them in at this stage. I don't think I have any specific comments, but Mr. Spavieri said that the connection is bad, so maybe he wasn't hearing us. I don't know. Yeah, I'm surprised. There are a couple of us here. Vladimir was here, but it says device is not connected. I don't know what that means, because I was going to beg for some help from some of my regular colleagues to, dig down a bit into what this is all about. Look, we have a very logical thinker in our regular participation, if I may say so, without appearing a bit condescending, and that's Mr. James J. Keane. So, Jim, I'm going to impose upon you, if you'll forgive me, to help me to sort this out a bit by maybe using your simple logic. Let's not go into too much detail, to try to interpret between Sankar Hajra and us. And I'm including us because, I know the way you think, if I may say so. You probably know the way I think. We're regular participants. And if you could maybe, ask a question or clarification or even critique something that Sankar Hajra has said, or even support it. Any comments from you, Jim?
Dr. Hajra, what year did you write this book on? What year? What is the date?
When did you write this book?
Writing.
1990?
Did you write this recently, or was it many, many years ago? Is that your point, Jim?
Well,
No.
Was the answer 1990?
19?
Why do you ask that? 1990, around that special date.
Oh, 1919. Okay, well, there are many dozens, if not hundreds, of critiques of special relativity. And so I'm wondering what is new or novel in your presentation that motivated you to, or does this simply repeat?
Kindly writing. I will answer. Writing.
So, I even said that some of my ideas I could see in yours and others. So I suppose Jim's point is, what is new in your system? The other people,
Yes.
You quoted Beckman yourself. What's different in your system? What's novel? What's new? Yeah, I think we might be having difficulty actually in Sankar Hajra's hearing us. He's delivered this, and I thought he had an interpreter there actually, but his English is fine. I think he's having difficulty hearing us. Can you hear us? Can you hear us, Sankar Hajra?
Please ask me writing. Please ask me writing.
Ask him in writing.
Yeah. Well, I just might make.
Can you go into the green room chat?
Oh, I have written a book this year. I have published this year. I am sending this to you.
Well,
Can you read the comments, Hajra? I said, what is new in your theory? A bit bluntly. Okay. You see, Hallam has said, yes, for Beckman, the book is available on the internet. I think Jim asked the question. He says, Professor, where does Beckman use Poisson equation in Einstein plus 2? Well, it's an internal. Okay. Okay. Yeah. Well, Jim.
Well, I might just add a few comments.
Go ahead. Please do.
He talks about that Newton's and Maxwell's equations explain things. I would humbly suggest more that they describe phenomena without an explanation. For example, there is no mechanism of motion given by Newton, and binary mechanics, my own work actually gives a mechanism of motion, but without so you're talking about describing phenomena. Now, in the Lorentz transform, you mentioned all laws of physics. Well, if time is involved in your transform, then time is no longer an independent variable, and therefore there are no laws of physics, at least those that require, and most do, the time as an independent variable. The other thing that I might mention is fractional electric charge. Recent data shows that the electron, as well as the so-called quarks, constituents of protons, exhibit the phenomena of fractional electric charge, exactly 1/3 of the elementary charge of the electron. Your work seems to doesn't take this into account at all. So I guess those are just some comments I might make. And my general comment is special relativity has been discredited by so many different authors. Again, I'm sort of wondering why you're even pursuing this. It's like what we call in English beating a dead horse. The horse is dead. Why do we need another treatise killing the horse when the horse has already been dead for a long, long time? End of my comments.
Okay, very valuable. Thank you very much for helping us. I mean, I might interject, I hope not too roughly, that yes, we dissidents would agree with what you've just said, Jim, and this is true. And there's so much information there, and they've been giving information, they've been giving references in the chat there about the Einstein +2 and Beckman and all that, and Jim thanked us and so on. However, the vast majority of the career academics, if I may call them that, the politicians and the media, just take the tripartite there, they don't agree. They conceive of the special theory of relativity as being, well, you might say, what do politicians know? But they are the spokespeople and the career academics, and they say that it's true, and you're just wasting your time. So that in itself is presumably a justification for yet another attack on something that is believed to be incorrect. But what we'd like to know is what you started with. What are his separate elements? What are his new elements that haven't been expressed elsewhere?
Ian, there's a fallacy in that analysis, if I may humbly suggest it. It's called the bell-shaped curve of IQ. And just below on the fringe on the lower right of the bell-shaped curve is your highest IQ people. If you move down toward the center of the bell, that's lower IQ people. Adding more presentations to kill the dead horse again of special relativity is not going to affect that lower IQ group of people. It's just not going to happen. That's just what the bell-shaped curve intelligence tells us. So that the whole idea is that we need these kinds of presentations to sort of convince the lower IQ cadre in this bell-shaped curve to change. Well, you can't change their IQ. They're where they are for a reason. End of my quotes, or end of my comments. Thank you.
I'm sorry to be getting in, and Sankar, Hajra, we really want you to come in, but in the interim, I would say we really need to have this discussion more. You've raised some very interesting points there, Jim. We need to have this discussion more between ourselves, and maybe on the Sunday presentations or some other presentations. It's a very good point, but I would differ to a certain extent in this way. I probably have more respect, in inverted commas, for these what I call career academicians than you do. You seem to be putting them down in the low IQ. I think some of these guys have very, very high IQs. They're brilliant. They can solve equations and so on, but they're prejudiced by the generality of views, and also unconsciously by the possibility that their careers could be affected. It's basically a groupthink. I think the people, the groupthink people who don't think for themselves, that's a majority of people, and are probably in the center of the bell curve. Their IQs are between 95 and 105 or something. They seem very stupid to us. When somebody like Sankar Hajra raises these points and puts in these equations and puts in these Thomson equations and so on, we say, yes, why do these people need to be told this? Because they're just stupid people. But so at least we're agreed on one thing, I think, Jim, that it's necessary to give these talks, even if they're repeating ideas. And I agree with you. We'll probably never get through to the mainstream. But I don't know. Corey has actually said that he thinks, and I think he's probably right, Jim, that Sankar Hajra requires our questions to be written down in the chat. Now, there are two chats here. The one in which Cornelis has said that, I've just put back to him. I said, would you ask a question? And Sankar has just put a question, kindly ask questions in writing. So I have asked, I've asked Cornelis to put a question in writing. Now, I've put a question in writing. what is new in your theory? That's your question, but he hasn't answered it. So that's a question. We have put questions. Please answer. And I'm going to take the liberty of putting your question again, Jim. For example, what is new in capitals in your theory?
For
So
example,
if you could
all
answer
of
that
these equations omit fractional electric charge.
Yeah,
and
he didn't
actually,
answer
the
that.
most intelligent people in academia, the U.S. National Labs, CERN, elsewhere, are now producing data supporting the ideas of binary mechanics. So that I just wanted to throw that in. We have laboratories all over the world which are basically working to confirm predictions of binary mechanics. So those are very, very intelligent people. I just wanted to point that out. Now, hopefully others can chime in here, or that our beloved guest can respond to some of the questions. Thank you, Ian. You're
Thank you very much,
kind.
Jim. I've just before I let you go, I've put in, we're talking about binary mechanics. I've said, do you support the idea of quarks, Mr. Speaker? So maybe he'll answer that.
Or fractional charge, which appears in Lienard's equation.
1/3, 2/3. Yeah. Okay. Thank you very much, Jim. We're running out of time, but we may have to bring you back again because there are very few people here. For example, Vladimir seems to have disconnected. I'd like to brought him in. And I have a feeling, as I've said to you on previous occasions, that some of our regulars are in the social media watching this because they come in. Maybe I know who I'm speaking about. Maybe Harry comes in the next day and he seems to know what happens, but he's not here. Look, he's answered. I propose that the Earth carries electromagnetic field with it. This will explain why the Earth's surface is equivalent to free space. Yeah, he said that. I can't put that up because that's in the private chat. You see that? Okay. So thank you very much, Jim, for your comments, and please.
Thank you, Ian.
If you want to thank you for helping me out. Thank you very much. Okay. They will try to reconnect. Yeah, okay. Well, nobody else in the green room has access because Carl tells me that he can't actually, make his case in the green room. He can hear us, but he can't actually get in. Yeah, okay. So what Sankar Hajra has done is he said, what is new in his theory is he proposes that the Earth carries the electromagnetic field with it. This will explain why the Earth's surface is equivalent to free space. Well, I would say that, if you forgive me, it's not entirely new in the sense that I've said that as well. So at least we've both said that, maybe independently. Okay. So I think, let me see. I'll just actually see. I sort of asked people to leave the green room when we're full, but I'll ask them to come back. So I've just sent him a call there to come back because he might want to ask something. Let me see now. Okay, if Cornelis comes back, we might give him an opportunity of asking. But it looks like the rest of the discussion will be between me and Sankar Hajra, which I hope doesn't bore you too much. And the reason for that is myself. I think I'm the more boring person there. We haven't got that much time left, but I want to fill the 2 hours. I don't want to stop it early. Jim says, yes, Sankar did not distinguish between his new ideas and those previously stated by others. Yeah. Well, the only thing I would say is perhaps Sankar Hajra doesn't know about these other ideas. I don't know. He tells me that he was involved with the NPA many years ago. I think he gave a presentation, but we are familiar with all these ideas. Presented by us, by our regular contributors, but also people like Beckman and other people who've written, Kelly and Dingle and all the rest. I don't know if Sankar Hajra is familiar with these, so maybe he's independently developed some of these ideas himself. I feel that many of his ideas are reminiscent of the ideas which I humbly have instigated myself, such as that the ether is largely dragged by the electromagnetic or gravitational field of the Earth. So maybe that isn't entirely new, but it is counter to mainstream. And I'm just looking to see other comments. Okay. What does Harry say there? He would say, I would discuss about what caused frame dragging and how it may relate to the index of refraction of the Earth's gravitational field. Well, if you would come in, Corey, you could do that directly. I don't know if you'd have much more success than we will, but anything in writing, I think Sankar Hajra can deal with. Here's another private chat. Why does Sankar's equations contain SR gamma factor? Can you see James Keane has asked, why do your equations contain the gamma factor, which is an indication of special relativity? Would you care to deal with that, Mr. Speaker? Yeah. Okay. I'm even going to put is the man next to you speak to me? See, I thought this I thought he was maybe his son. He looked like a younger man or something, or a colleague there. Because Sankar Hajra has, he told me, difficulty hearing sometimes. So is the man there beside you able to speak to me? No? No. Well, we're not really getting a response there. But I will say that having had the presentation today from Sankar Hajra, we have his contact. I have his contact as moderator of these sessions. And if anybody wants to be put in contact with him through email, for example.
Yeah, Mr. Ian, I am speaking something to you. I have propounded in my talk that electromagnetic fields see real physical entities, and the Earth is carried electromagnetic field along with it. It will explain all electromagnetic phenomena easily and rationally. It will explain all electrodynamics can be explained from Heaviside electrodynamics, all electromagnetic phenomena, and all piling phenomena, that is Michelson null result of Michelson experiment, that is the Taunton-Noble experiment, or the Michelson-Gear experiment. All the experiment can easily explain from the consideration that the Earth carry electromagnetic field along with it. Electromagnetic field along with it attacks the electromagnetic field and carries with it. It will easily explain all electromagnetic phenomena easily and rationally. No relativity is needed. I have 2 points. First, that all electrodynamics is the outcome of Maxwell only. No need of relativity. All electrodynamics that is treated by relativity is the outcome of Maxwell. this can all deduce from Maxwell. And piling phenomena, that is microscopic experiment, Michelson-Gale experiment, Bradley observation, all those can easily explain from the consideration that the Earth carries electromagnetic field along with it. This is my contention, nothing else. Relativity can be replaced by this consideration that Earth carries electromagnetic field along with it. And other electrodynamics, that is the outcome of Maxwell. No need of relativity is required there. Have I been able to have my
Okay. So the comments we're putting in the private chat there is just Jim.
Have I not been able to propagate my view to you, convey my view to you? Have I not been able?
When you were giving the lecture, I say anyway, I could understand. You were speaking slowly and you had the text in front of you. But now in the conversation, you are speaking too quickly. So it's very difficult to interact.
Okay. Yes. I have only two simple consideration here. I have only one. First is all electrodynamical calculation done by relativity is not of relativity. It is of Maxwell. It is from Maxwell. All electromagnetic momentum, kinetic energy, electromagnetic mass, and all electrodynamics is not an outcome of relativity. It is coming directly from Maxwell. We can explain. And second, the piling phenomena, that is microscopic experiment and all others, that will be the experiment from the consideration. There is no need of length contraction, no need of time dilation. All these are not needed. We can only explain all those phenomena from the easy consideration. The Earth carries electromagnetic field along with it. Then all electromagnetic field, the Earth's surface will act just like free space. This is my only these two concepts I have conveyed.
Cornelis, are you there now? Could you come in and maybe try to help us a little?
Well, I'm here. You can help or not.
Here. I hear you, but I don't see you. It doesn't matter. That's fine. It's just you were interacting, and I apologize. I asked maybe you and another man to leave, and they left. But this other man, he wasn't on. He's gone now. Anyway, so we've plenty of room now in the green room. So if you, and I just alert you to the fact that we're having great difficulties, Cornelis. But if you would either like to raise a point with our speaker today or put it in the chat, it would help, because you don't want me just spending the next 10 minutes before we finish speaking to Sankar.
Well, I don't know if I have too much to add, because I was having great difficulty.
Cornelis, have I not been able to convey my views to you? Have I not been able to?
So we have one of our participants, Mr. Cornelis.
Electrodynamics.
Verhey.
Outcome of Maxwell, not of Albert Einstein. They are all contained in Maxwell. We can deduce all those results from Maxwell. Only puzzle is the microscopic experiment, Bradley's experiment, only microscopic experiment. But these experiments, the piling phenomena, can easily explain from the consideration that electromagnetic field are carried with the Earth. Nothing else. My condition is this. I have no new contribution. I have only connected Newton with Maxwell. Through gravitation.
Okay, so there he's dealing with. Maybe it's not new. He's conceding that it's a consolidation of some ideas put together in his own analysis. I see Roger is perhaps acting for the floor. I'll bring you in a second, Roger. If we just see maybe Cornelis. I know I'm imposing upon you, and it may be difficult because you have some interesting ideas, but I don't think we'll be able to get them across. But if you'd like to say just one or two words before I bring Roger in, Cornelis.
Well, for the most part, I did have quite a bit of difficulty following the talk, and part of it was I have a new phone, and I was trying to do it on a phone. I had difficulty getting into the green room originally, and then now I'm doing it on my laptop. But at any rate, I also had difficulty hearing of hearing aids. So all in all, I didn't hear too much of the conversation, and I'm going to have to go back and listen to it later in a better light. But what I asked in the chat was basically about, it seemed like there was discussion about frame dragging or ether drag around the Earth and that, and how it caused the light to bend. And so I'm just wondering, what people think about the Earth gravitational field rotating with the Earth versus, being stationary. I'm of the opinion that it rotates to an extent that all particular matter, atomic matter, has really no limit to its energy wave pattern. So as a particle moves around the Earth, so does an equivalent, pattern extend all the way into space. It weakens with distance, but the sum of all of those patterns rotating together causes the waves to just move around. Those waves would be moving with the Earth, not just out away from the Earth and back towards the Earth. So it's like if you were to put a dozen raindrops in a circle on the surface of water, and then those raindrops propagated through the water surface in a circular motion, then you would encounter a boat or anything and would encounter those waves rotating past them, no matter how far you are out. And it has to do then with wave entanglement and entrainment. One wave will follow the other and eventually catch up with it. The front one will slow down, and the back one will front one will slow down, and back one will move towards each other to become a single wave. And so anything that it encounters, including light, as the light encounters those waves coming down, it's going to be starting to be drugged by those waves. The same thing is happening in the experiments that we do, where we have moving water through a tube, and we shine light through that tube. It's drugged with that tube, and that's based on the refractive index of the water.
But Corey, thanks for all that. And the positive thing is it's recorded now. It's recorded as a comment after the lecture. But I really think
running out of time.
I think you've lost your speaker, and I don't think we're going to be able to get an answer to that. Thank you for making those points. We have them recorded, and we'll come back to you if necessary. And if you forgive me, I'll bring in Roger now, Corey. Thank you.
That's great. Fine.
Thank you. Roger.
Okay.
There you are.
Thank you. Okay, thank you. You're doing a good job, Ian, despite all the problems.
Well, thank you. Is that all you wanted to say?
No. I said to get. I'm just going to say, when I came back in the game to StreamYard, just it's a technical thing. It was saying there was some sort of problem with Sankar's computer, and the message is gone now. But part of the problem we've had a lot in the past with StreamYard, if the computer's not really up to handling these things. And also another issue is it's best to use these headphones. So that might be part of what the problem is here.
Okay, that certainly could be useful for Carl, because he's told me, and you've probably seen the comments, that he cannot get in, but he's having difficulty going through the social media. So he always goes into the green room, but he's only listening. He's not contributing. Now, I had another two people that you probably saw, because you're administrator as well, Roger, whom I didn't know. And one of them I brought up a moment ago, Sally, I've forgotten his name, something like that. And he wasn't responding, but I could see his photograph.
Yeah.
The other gentleman, I didn't know who it was at all, and he disappeared early on. And I had 10 people in the green room, so I couldn't bring anybody else in. Hence my asking people to leave.
It's the old ugly, anyway. Yeah, it's the ugly problem with StreamYard again, sort of thing.
Yeah. Okay. Well, we've had a problem.
With so many.
We're going to have to discuss it a bit further among ourselves. I know, Roger. But thank you for your kind comments, and I'm doing the best I can. I'm a little upset that some of the very interesting points that are actually in Sankar's presentation, we haven't really dealt with them in regard to the questions. But again, I'd say the same thing that I said to Corey a moment ago.
Yeah.
At least it's there recorded, and we can go back and we can expand the screen and we can have a look at his equations, and we might even be able to start an email on it.
Yeah.
So thanks very much. I better wrap up now, hadn't I? If that's all right.
Thank you. You're doing well.
Thank you very much, Roger.
But StreamYard doesn't help you. StreamYard doesn't help you.
I know. Thank
Keep
you.
at it.
Thank you. Okay, now before we finish, time has caught up on us. There's some further things about this gamma factor. Actually, Sankar Hajra has said that the gamma factor is coming from Heaviside.
Yes, it is first coming from Oliver Heaviside. Oliver Heaviside that deduced the result first.
But I mean, maybe it originally comes from people like Voigt before Heaviside.
Oliver Heaviside.
Voigt, the Voldemar Voigt did some work where he brought this gamma factor in. He was looking at the Doppler effect, actually. But the gamma factor comes in a lot of analysis. I mean, a person like me who counters not only special relativity, but the Lorentz transformations in any form, whether it's Lorentz theory or SRT, the gamma factor comes in because it's a mathematical sort of relationship. Anyway, look, we're going to have to leave that there. Jim Morrison has come in. Did you want to make a quick point, Jim, or we have to wrap up now, Jim? But since you've just come into the green room, you might be able to help me. If you are, we can only take a minute or so. But if you have any comment, good, bad, or indifferent, or if you'd like to pursue this in some way further, because we're not able to get very far, I think, online. No, okay. If you want to make any comments after they talk by email,
I just wanted to, put in my my normal 2 cents that you don't need the gamma factor if you assume the ECI and that the Earth rotates within it, and that Marcus and Morley it's not null. It's just too small to measure if that's the relevant speed.
That seems to be an agreement largely with Sankar Hajra's thesis, doesn't it, Jim?
Actually,
you're almost saying the same thing.
I tried to listen, but I just couldn't follow what he was saying.
Okay, well, I say this to you and to myself and to everybody else. You might look at the recording and try to solve it. So thanks very much, Jim. I'll bring it down for a moment because well, if I can remove you. Yeah. So Sankar Hajra, I'm going to give you a minute or two just to summarize and conclude. If there's anything else that you want to say before we finish, we've only got a few minutes left, and then I'll come back and officially close the meeting. So if you want to say anything more, the floor is yours now again.
বুঝতে পারলাম না হলো না কিন্তু এখানে উত্তরটা দিয়ে দাও, যেটা লিখছি লেখাটা দিয়ে দাও, বলতে দরকার নেই, মুছে দাও। কমেন্ট লোক করে না, 6 জন হচ্ছে মানে প্রফেশনাল লোক ছিল, 6 জন। তোমাকে নিয়ে 6 জন প্রফেশনাল লোক। তোমার ইমেল অ্যাড্রেসে দিয়ে দাও, না লিখতে হবে, তোমার ইমেল অ্যাড্রেসে দিয়ে দাও, হয়ে গেছে তো তো দেওয়া আমার কি আছে।
Maybe you've said enough. So I'll take the floor, and I'll try to be brief and clear. I hope. Well, I know we've had some considerable difficulties in our interactions, and we talk sometimes about mathematics and maybe different mathematicians finding it difficult to relate to each other. Although mathematics is a fairly universal language, and we normally don't have difficulties. We have arguments about small things. Here, we're not arguing about the usage of language and convention and so on. There's no problem. We're all speaking the English language and all pretty well, I think, but we just have problems in interpreting what we're saying. Intonation has been used a lot. I had another speaker who has perfect English, as far as I can see, and he's hesitating to give a talk because I think he talked intonation. And I had another person back who said the same thing. So that's one thing, and that's a problem we have maybe with not just with StreamYard, but with this participative system. On a one-to-one basis, it's easier to make oneself clear. Very, very difficult on this system, and people can be misinterpreted. However, having said all that, I, for one, have been quite interested in the material that Sankar Hajra has given us today. And I'd like to look into more details on the published material. I wasn't aware of this, and I'm glad I'm aware of it from my own selfish point of view, because it relates to the areas that I'm particularly interested in, which is basically concerned with electromagnetic radiation and inertial frames and Coriolis forces and all that sort of thing. And he's dealt with those. So I think there's a marriage between some of Sankar's ideas and my own. There may be some disagreements as well, but I'd like to look into those in more detail. And I really hope that my cat thinks it's time to go now. I really hope and trust that today's lecture, and particularly the difficulties we've had in the discussion, have not put you off, because I'm looking forward to the next lecture. He's going to be using his principles now to extrapolate to GR. He's shown, according to his own light, I would say, that the base of SR has been taken out by this. So much so that Jim Keane has said, why give the lecture at all? Because we all know that. But I say, no, we all don't know it. We here know it, but not the people at large. So I'd like to see how he's going to apply his principles to the gravitational business and the whole idea of warping space-time. And I therefore look forward to our talk next week. And I would ask our speaker, actually, if there's anything he's dissatisfied with today, or anybody indeed, for GR Talk, focus on about a fifth of the content presented today. Yeah, well, there's a comment. There's a comment. If anybody has any other comments for the speaker, or the speaker has any suggestions for me as to how I might improve the delivery and the participation of all our participants, I'm sure I'd be missing some of the comments which are just coming in. Well, please let me know. I'll do my best. I have 2 weeks to do it, but I think it would be a pity if we said, oh, there are so many difficulties that we won't extrapolate to GR. We have that down for the next time, and I'll be announcing that in due course. So I'm going to terminate today's talk. Thank you all very, very much for participating. Thank you for your patience. It must have been a bit difficult when we were asking questions and getting no response, or when maybe the speaker was saying some things and we found it a bit difficult to... I shall do. For see that the speaker has responded. He's taking into account. He's going to look at this again, I dare say, and look at our comments, and he's going to respond. And rest assured that I'll continue to act as the conduit for his comments, and I'll consult with all of you in regard to any further talks. So thank you all very much on the social media. Thank you, everybody in the green room. I'm disappointed maybe I didn't have more people in the green room, although I know I threw 2 people out initially, but anyway, they didn't come back. I would ask you to bear with us, and it might clearer once we have the second lecture, because some of the aspects to that may fill in some of the gaps that have been created today. This is a new subject to me. Well, as I say, I'm seeing a lot of similarity with my work and other work, as James Keane has said, but it is a new avenue. So I trust that once we get to the second lecture, things will be clearer. So my last pleasant duty is to express my extreme thanks to our speaker today, Sankar Hajra, for having come, I think, late it's late now in the Indian subcontinent, and he's given us the benefit of the 2 hours. He's spoken very clearly. Actually, he's spoken clearly. The questions were a bit difficult, but I think he's going to be reading what we've written, and he's probably going to send me some emails. And as I say, rest assured that I'll deal with those. So thank you very much, Mr. Speaker. Thank you so much for coming to us today. And we look forward to your next presentation in 2 weeks' time. So I'm going to end the stream now, wishing you all a very, very good day. And thanks for your participation. Good day.